Hello again. Today we're going to continue looking at expanding quadratic expressions. As a warm-up, pause this video and expand the quadratic expressions given here. So for the first one, we're going to multiply the 2x by the x and the 2x by the 5. So we get 2x squared plus 10x. Second step, multiply the negative 3 by the x and the negative 3 by the 5. So we get negative 3x minus 15. The next step is to collect your like terms. And we're now done. For example B, remember this is the same thing as 1/2 x minus 3 times x minus 3. So we're going to take the x, multiply it by x, and then multiply it by negative 3. So remember, it's easier to start with the brackets before you multiply by the fraction. So we're going to get x squared minus 3x. Then we're going to multiply the negative 3 by the x and the negative 3 by the negative 3. So we get negative 3x plus 9. Same as the other example, we're going to collect our like terms. And then finally, we're going to multiply out that 1/2. So we get 1/2 x squared. Half of 6 is 3, and then plus 9 over 2. All right, on to example number 1. So again today we're going to look at creating expressions using our factored form and then converting it to standard form. So in example 1, the x-intercepts of a parabola are 2 and negative 4. The parabola crosses the y-axis at 24. Determine the quadratic relation in standard form. So for this, I like to start with a picture. So let's start by adding the axes. So there's our y-axis. There's our x-axis. Next, let's sketch this graph. So we have a 0 at negative 4. We have a 0 at 2. So let's put those in. So the x-intercepts are the zeros. We have a point at 0 and 24, where it crosses the y-axis. And if we like, we also know the axis of symmetry. The axis of symmetry, remember, is the average of the zeros. So it's x equals x1 plus x2 over 2, which equals negative 4 plus 2 over 2, which equals negative 1. So let's add our axis of symmetry. So we'll draw it right here. There we go. And now if we sketch that parabola, we know we're going to have a maximum where our axis of symmetry is. We don't know what it is, but that's okay. So there is a sketch of that parabola. We want the equation in standard form, but the only form we're able to find equations with is factored form. So we're going to start there. So using factored form, we get, remember factored form is y equals a, x minus x1, x minus x2. First step is to sub in the zeros. So y equals a, x minus negative 4, x minus 2, which is ax plus 4, x minus 2. After you subbed in the zeros, you sub in a point. The only point we have is 24 and 0. So 24 goes in for y, 0 goes in for x, and we can now solve for the a value. So we get 24 equals 4 times negative 2 is negative 8. And then we want to get rid of that negative 8, so we divide both sides by negative 8. And we end up with a equals negative 3. So what we have now is our equation in factored form. Y equals negative 3, x plus 4, x minus 2. Again, to quickly go over that, to highlight some of the key points. Using factored form, we get the following equation. Remember, the first step is sub in zeros. That's what gets us from here to here. And then once we sub in the zeros, we sub in a point. And once we've done that, we have our a value and we have our equation in factored form. But we want it in standard form. So to get this into standard form, we're going to have to expand this equation. So expand to get into standard form. And remember, this one has the 3 factors, so I'm going to start by getting rid of the last 2 brackets. So let's start there. Alright, so we have y equals negative 3, x times x, there's our x squared, x times negative 2, a negative 2x. So there's our green arrows, and then with our purple arrows we get positive 4x, and 4 times negative 2, negative 8. And finally a bracket. So next step is to collect those like terms. So we get negative 3, x squared plus 2x minus 8. And then the last step is to finally expand or distribute that negative 3 into the bracket. So we end up with negative 3 x squared minus 6x plus 24. So this is our equation in standard form. Remember, factored form is above here. Standard form is now what we have it in. So it's the same as what we did before with factored form, except now we take the extra step and expand the expression. Alright, and final example. Let's go to a word problem. So the University Bridge in Saskatoon has an underside in the shape of a parabolic arch. The arch has a maximum height of 5.8 meters and is 28 meters wide. Determine an algebraic expression in standard form that represents the shape of the arch. Of course, we're not going to start in standard form, we're going to start in factored form. And there's 2 ways we can look at this. There's actually more, but there's 2 ways that I'm going to show you this, answer this question. But first of all, let's add what we know. We know it's 5.8 meters tall, and it's 28 meters wide. That's probably not this picture here, but the one above. But here's one just zoomed in. So, there's 2 ways we can draw this. Some people like to start with a picture like this. Other people like to draw it like this. In either way, you will get an expression that represents the arch. If we start with the first one, we have a 0 at 0. And since it's 28 meters wide, we have a second 0 at 28. Looking at the second picture, if we split it in half, we have zeros at negative 14 and 0. And we have another 0 at 14 and 0. Next is to state the vertex. Since we know it's 5.8 meters high, since this is on the y-axis, we have a vertex at 0 and 5.8. In the second expression, we have a vertex at the axis of symmetry and 5.8. And the axis of symmetry is the midpoint of 0 and 28. It's in the middle of here, which is going to give us 14. So there are the two pictures. And from here we can model these two pictures starting with factored form. So I'm going to start with the left one, come back and do the right one. So we start with y equals a, x minus 0, x minus 28. We don't actually need to write that 0, so another way to write this is y equals a, x, x minus 28. If you like the bracket, you can keep it. Next, we sub in a point. The only point we have that is not the zeros is 14 and 5.8. So 5.8 is our y value, and 14 is our x value. Now we need to solve for a, so first let's multiply. Mistake there, sorry. We end up with 14 times negative 14, which gives us 5.8 equals a, and 14 times 14, negative 14 is 196. Negative 196. Divide both sides. We get 5.8 over 196, the negative of that. And we can actually reduce this a little bit. First I would change it into whole numbers. Take out the decimals, multiply top and bottom by 10. And finally divide top and bottom by 2. And we get a divide 1960 by 2, and I believe that is 980. So there is our a value. So we have that the height of the parabola is negative 29 over 980 x, x minus 28. There it is in factored form. So what we need to do next is expand this expression. So I'm going to take this thing, multiply it by this, and multiply it by the 28. So there's our factored form. But it asks for standard form, so now we're going to expand. So we get y equals x times x is x squared, negative 29 over 980 x squared. Then we're going to multiply. Remember that 28 is 28 over 1. So when you multiply fractions, numerator by numerator, denominator by denominator. So I get 29 times 28. I'm going to need my calculator for that one. I believe that's 812. And then 980 times 1 is 980. And then we're going to take this one more step further. We already reduced this fraction earlier. 812 over 980. When I reduce it, I end up with, and notice I missed an x here, I end up with 29 over 35x. And there's our expression in standard form. All right, back to the second version of this question. And you decide which one you think is easier. So that's y equals a, x minus negative 14, x minus 14, which is equal to a, x plus 14, x minus 14. And again, most of you can skip right to that step. Sub in our only other point, 0 and 5.8. So I get 5.8 equals A, 0 plus 14, 0 minus 14. That's 5.8 equals A, 14 times negative 14. And notice that this is going to look the same as what we had the first time. We have to divide both sides by 196. So we're going to get A equals 5.8 over 196. And then same as before, we're going to have to reduce that. And we're going to get A equals negative 29 over 980. Notice the A values are the same. And they should be. It's the same parabola. It's just shifted over. So when we talked about the A value is how wide or how narrow the parabola is. So these two should have the same width. Alright, the next thing to do is to get this into our factored form and then expand it. So this is 29 over 980 times x plus 14, x minus 14. We're going to apply our distributive property. So we're going to multiply this by this, this by this, and we're going to multiply these together. So let's do that. So we get negative 29 over 980. Following the red arrows, I get x squared minus 14x. Green arrows, plus 14x minus 196. That equals negative 29 over 980. That gives me x squared minus 196, since the 14 and the negative 14 will equal 0. And our last step is to distribute this fraction into the brackets. So the x squared is just multiplied by 1, so we're going to multiply it by negative 29 over 980 times 1 is just negative 29 over 980. And then we've got to multiply the 196 by 29. Remember, that's 196 over 1. So that gives me, if I use my calculator here, 5,684. And then over 980. So we're almost done here. Negative 29 over 980 x squared. We need to reduce that fraction. And if you try to reduce it, you should get 29 over 5. Keep on dividing by 2. Or divide by bigger numbers. Figure that out. Or use your calculator if it does that for you. So again, there is our standard form of this expression. And our factored form up here. In order for us to get an equation from a graph, we're going to start with factored form. If it has to get in standard form, then you take the extra step and expand that expression. So today there's a couple questions from the textbook, and then I've also made a handout which includes 3 word problems you can try out. That'll also be available to you through D2L. Till next time.